a PowerPoint presentation, as you will see, and I hope this will help us our important role as engineers in Nigeria. We seem to be taking a back seat. We don't seem to be in the forefront of change in this country. And that narrative must change if Nigeria is to get better. Somebody has already mentioned the relationship between the scientists and the engineers. An engineer is a problem solver. Wherever there's a challenge, an engineer will always find a solution to those challenges. Even where the sciences fail, there are areas where science has failed. Science has not given answers. Engineers will always find a way out. I will give a typical example. Let's take something very fundamental. Fluid flow. When liquids or air or any other fluid flows in a pipe, we recognize two major regimes: laminar flow, turbulent flow. Laminar flow, one layer is flowing over the other layer. There is no mixing between those layers, isn't it? When Reynolds number is below 2300 in a pipe, you have laminar flow. When Reynolds number are 10,000 and above, you have turbulent flow, isn't it? The mathematical modeling of these two, laminar flow has been modeled more than 200 years ago by two great scientists, one in France, one in the United States, but they came with the same solution. Those second-order partial differential equations, we know them. The famous Navier-Stokes equations. We teach undergraduate students these equations every time. These equations, we know, have only modeled laminar flow. Nobody operates his machines in the industry under laminar flow. If you have a reactor, you run it under turbulence. If you have a heat exchanger, you run it under turbulence. Because turbulence gives you higher transfer coefficients, whether heat is being transferred or mass is being transferred. You get maximum under turbulence, isn't it? Yet, there is no equation to describe turbulence. Scientists are yet to do that. 200 years after the famous Navier-Stokes equation, we are yet to get partial differential equations for turbulence. Yet turbulence is the oldest phenomenon in nature. At the beginning of time, there was a time when there was no time. There was a time when there was no space. No space, no time. That was the beginning of turbulence. There was only Allah subhanahu wa ta'ala. No malaika, no human beings, no earth, no universe, nothing except Him. And He decided to create the universe and its contents so that the nature there will recognize Him and worship Him. That was what the scientists call the Big Bang. They claimed there was matter created, but then they misunderstood the whole thing. They didn't want to recognize Allah. They said there was antimatter. That is if you ask a scientist what is antimatter, it doesn't make sense. They said if you bring the matter and the antimatter back, they will give you zero. Because they didn't want to recognize Allah Ta'ala. But we do. When that Big Bang occurred, The first phenomenon there was turbulence. Movement of gases in high speed. They created the different galaxies that we have, millions of stars all over, including the Milky Way, which we belong to, including the solar system. The sun is the closest star to us. We see it so huge because it's the closest to us. And the universe is still expanding. If you go into space, time you are measuring with your clock dilates. Space also dilates. When you that's the essence of Einstein's theory of relativity. Whatever you measure is relative to your own speed. If you approach the speed of light, the distance you measure will be different. The time you measure will be different. I don't want to go into that. It's another topic altogether. I'm bringing this to show our turbulence, which is the beginning of everything. Up to today, science has no solution to it. But engineers have discovered a solution. And the solution is simply those equations that we use in our design. Correlations. Engineers run experiments across different Reynolds numbers, across different other property numbers, Prandtl, Biot, Nusselt numbers, etc., different ranges. And they came up with correlations to describe turbulence. Daitos-Boelter equation is one of them. We teach students that in heat transfer. Nusselt is equal to 0.023. Prandtl raised to what? 0.833. Reynolds raised to 1/3. Then the ratio of viscosity follows. If your fluid is very viscous. They will tell you this equation is applicable within a range of Reynolds numbers. Because those who did those experiments carried the experiment within those range of Reynolds numbers. Engineers have given us a solution. The only theoretical equation I know on turbulence was the one developed in the 1950s by Kolmogorov of Moscow State University. You know, but even that equation can only give what they call Kolmogorov length scale. Meaning the size of your turbulence. Is it in a teacup or is it a Katrina somewhere? That's all it measures. Not a modeling of that, what's happening inside. So engineers, we have always brought solutions. I don't know why Nigerian engineers are sleeping. Nigeria is grappling with a lot of challenges. We are not seeing any serious solution coming out of our faculties of engineering. What went wrong and what's wrong with us? We have to wake up. A lot of researches are being done. A lot of inventions are being done. Inventions are not innovations. Inventions are not innovations. An invention can become an innovation if it hits the market, as you said, if it hits the economy, if the industry adopts it, if it makes economic sense. Otherwise, we're just gathering, equipment all over, littering the space, writing journal papers, getting our professorial promotions. And the economy is still lingering in very serious challenges. We have to wake up to this. This to me is the summary of my paper. But I'll go through the slides. Now, the first slide, next please. Nigeria's industrial crossroads. The Vice Chancellor quoted the GDPs. Industry manufacturing just 9.2%. Is very low. Our dependence on oil is also creating a lot of challenges, vulnerability because of the volatile global oil market. This limits capacity. The next one, please. We must therefore diversify the Nigerian economy. Next, from oil dependence, you see, what makes, if, for example, you create an equipment in your faculty, in the first place, do not do research without consulting the end user. Somebody will talk on this anyway. You must engage the industries in Kano. What are their challenges? How many times has the dean and the HODs visited those industries in Kano? I should ask that question. How many times? We must engage them, know their challenges, see how to address that. 80% of the industries in Kano have already closed down in the last 20 years. Some have moved to Lagos. Some have moved to Ghana. Why? We need to find out. And as engineers, bring out solutions to those challenges. That's the main problem of our research. We operate in silos. We don't reach out to the end user. And at the end of the day, whatever we produce continues to stay in our faculty shelves. We therefore need to interact with industry so that we can do research that makes sense. These are all part. Nigeria is greatly blessed in agriculture. We need to leverage on that. Malaysia came here in 1960s. Tuanku Abdurrahman, the Prime Minister, visited Tafawa Balewa around 1963. He was taken to Benin, and he saw the palm oil plantations, and he asked for samples from Nigeria. They took those samples to Malaysia. They improved on them, and by the time I was teaching in the University of Malaya, Malaysia was in charge of 55% of the world traded palm oil. And they got their samples from Nigeria. Not only that, the beta-carotene, which gives palm oil, is red color. They extract it, send it to the pharmacy industry. There are certain oleochemicals, which are very good natural lubricants. They extract it from the palm oil. They only leave the triglycerides, package them in bottles, and sell it to the world. Nigeria has been sitting on palm oil for a very long time without realizing those values. Asia has now come and picked it up, and now they are growing very fast. We have other products, solid minerals, etc. We have policies in place, paper policies, most of them. We have institutions and agencies on ground. We have universities and polytechnics in hundreds. Yet, Nigeria is yet to reach the promised land. The next one. We have failed to reach the promised land to make Nigeria self-sufficient. Today we are importing almost everything we consume from China. Even the textiles we are wearing is from China, most of it. Anytime we wear a cloth from China, take note, you are helping to keep employment of youth in China, and you are denying Nigerian youth employability. We need to, at least, the clothes we are wearing in Nigeria, we must revive the textile industry. This is my point. Kano and Kaduna used to be the hub of textiles. Kaduna textiles at one time, all of them closed down due to the cost of heavy oil. At that time, it was selling at 40 naira. It rose to 80 naira per liter. They couldn't afford it because when they produce with high energy cost, they end up not competitive. Prices of products imported from China became cheaper. That way, they had to close down. The same thing happened with Dangote, with the Bachita Sugar Company. I did my IT in the 1970s. When Dangote was allowed to bring in sugar without import, without any tax. The price at that time, Bachita was selling sugar for 3,500. Dangote Sugar was selling for 3,000. So Bachita Sugar Company had to close down. The same thing with many other industries. So we must therefore change the way we do our things so that Nigeria can at least be self-sufficient. The next one, please. The industrial crossroad. In this paper, we shall attempt to find out what went wrong, to make an attempt on solutions, and to propose sustainable industrialization midwife by engineers. I shall also critique some of the current status quo. But please, and I please, take it in good faith. Yes, I will criticize a number of the government agencies. And we have a former minister here sitting with us.